in the years 2006, 2005. It's taking me forever because I blame myself. I wish I would have said like make 2000 year 0, make 2006 year 6, and make 2008 year 8. I wish I would have been more definitive on that, and then those graphs would have been more uniform on your test. So that's just taking me a while to like sort through. Yeah. Because it was like your mind trick to say like October was 1 or something when you know like October was 10, right? Yeah, I agree. Yeah, no, it is probably easier now, but grading it taking it some time. Long story short, I haven't graded your test completely, and I'm already telling you, you have a quiz on Monday. I don't think you should actually take the test and break it down. Well, I'm gonna get them tomorrow. Yes. So before your first quarter grade is final, I got I think 2 or 3 weeks of homework to put in. I have your test to put in, and I have a Bower quiz to put in. So your grade right now is not what your grade's gonna be. Like there's a lot that's gonna go into it. So I haven't. So the quarter ends Thursday. Grades will go in Friday next week. A Bower quiz, a test, a 104-point test, and 3 weeks of homework. That's not going to make it. That's going to be in quarter 2. Yes. Oh, there's a rumor floating around that Monday's off, but I don't think so.
Don't go to school.
You won't be there anyway. We're missing the day after the concert, remember? No, there's definitely school Monday. You don't have Columbus Day off.
I want to celebrate Christopher Columbus. You just sit here and play video games all day. I'm gonna celebrate. You're gonna sleep
Let's
at
just
3
get that
o'clock.
guy off the calendar, can we?
You mean sleeping and playing video games all day? If it's that important to you, just don't go to school. Please take.
All right, so let's talk about this this last section. So, systems of linear inequalities. This is the easiest part of the chapter. Not to oversimplify it or make you think that it's so easy you don't have to practice, but this you'll find this goes pretty quickly today. We're gonna graph each inequality. If you remember, when there's an inequality symbol instead of an equal sign, it requires shading. You shade up or shade down, and then wherever there's shading for both of them, so I'll shade this one, and then I graph and shade this one, and where the shading overlaps, those are the solutions to the system. So I guess if I was going to add anything to these notes, it would remind you that if the problem is y greater or y greater than or equal to, you're going to shade up from the y-intercept. But if it's less than or equal to, shade down. The other thing we talked about with inequalities, if the symbol doesn't have the line under it, you should do a dashed line in your graph. And if it does, you should do a solid line. So you've done this graphing and shading before. The only new thing is that you're going to go 2 graphs on one coordinate plane, shade them both, and look and see where the shading overlaps. I'm going to start. Do you want me to wait? Do you want me to wait?
on October tomorrow. Yeah.
So Brayden,
Pokemon. What?
how do you graph this inequality? Where will my graph begin? Where does it start? How do we do it? This y-intercept is where I begin. It's on the y-axis down here. Begin on the y-axis and then move slope up 2 over 1, up 2 over 1. And then I connect with a dash line. I'm pretty okay with how I created this first dash line. Good with that? Started at -4. This is where I started. Up 2 over 1, up 2 over 1. It says y greater. So I come to this y-axis and I shade up from there. So the top inequality yellow has been graphed. So where do I start the bottom one? Yes, Cassidy? At +3. Wait a minute. I don't like this 0.5. When I have to graph, and I'm hoping to have a slope, it's actually one of the few times where I really prefer, I'm going to convert this decimal to a fraction. What's the fraction equivalent of 0.5? So I would prefer a fraction when it comes to graphing because that's rise over run. So I start at 3 and I go down 1 over 2. And this time I'll connect with a solid line. And this says y less than, so I go to the y-intercept and I shade down. And if you're confident in your shading, you can use a highlighter or a pen or something. What I'm looking for is the area where the shading overlaps. So all of the solutions, this green part is ordered pairs that are true for the top and bottom. So both of these inequalities have these solutions, not the yellow, not the blue, but right here where they overlap. So I really, really prefer for you to make a little note and show me that you understand where the solutions are. So solutions, and then just kind of point, this green area is the solutions. With pencil, you're going to shade light, you're going to shade light, and where they both are shaded, you're going to shade dark to show where they overlap. Who's got a question? All right, what's different about number 2? Mark? This is an absolute value graph. So this is kind of like a spiral review. You guys graph these, then I'm pretty sure you erased it out of your memory to make room for something else. Do you remember how to graph absolute value? It's the V shape. So this isn't slope or y-intercept. This is a V shape. Just throwing it in here. Do you remember this? This is the parent absolute value equation. The most basic. So this is the V shape. We're going to start right at the center. Up 1 over 1, and you just have to know that. That's something that you have to learn and remember and just know. Absolute value makes a V shape. It says y greater than, so I'm shading up, which just happens to be inside the V. We're good? Am I going too fast? A little bit. And then the second one's not absolute value. It's just a regular linear inequality. So I'll start at 5. Shoot, I wish my graph was just a little bit taller. So So I'm going to go up 1, 2, 3, 4. And it says y is less than, so I shade down from there. So this has got to be the best part of chapter 3, don't you think? It's coloring. It's graphing and coloring. Use your colored pencils if you want. So for this one, there's a very clear moment of interlap. It's like a rectangle shape, right? It goes on forever. So we got yellow, not a solution to the system. Blue, not a solution. Right here where they overlap. These are the solutions. This would be nice. That's clear. These are the solutions. So I could pick an ordered pair in here, plug it into the top, it'll work. Plug it into the bottom, it'll work. This point works for both of them. So